Hello guys, welcome to our first lesson of the year. We are going to be starting on Unit 1, which talks about voting theory. Voting theory is probably not a topic that's popped up for you before in mathematics. You've probably taken the more traditional mathematics courses such as Algebra 1 and Geometry. Maybe you were in pre-calculus or a class like that mostly focused on things like functions and algebraic type stuff. And this is more of a math that looks at daily applications, things that you might see in everyday life, and talks about the mathematical outcomes or the mathematical possibilities of those applications. So voting is definitely something that at least I hope you will do when you guys become adults. So understanding different voting systems that exist around the world besides just the ones that we use here in the U.S. Could expand your perspective on the voting systems that we use here. So my goal is just to kind of expose you to that, show you how it works mathematically, and show you some of the advantages and disadvantages of those voting systems, right? So there's just a lot of situations that we run into where we don't have an individual making a decision, we have a group making a decision, and not everyone in your group is going to agree on what decision to make. Okay, so we could be talking about a presidential election, we could be talking about how to distribute funds, we could be talking about something simple like a group of friends deciding what movie to go see. All right, so voting theory pops up quite a bit, and trying to find a fair way that accurately describes what the group consensus is something that has been debated actually for hundreds of years. All right. So to begin with here, we're going to talk about something called a preference schedule. And a preference schedule is simply a way in which the people who are voting rank the different choices that they have in order of preference. Okay, so you see this definition here called a preference ballot. All right, and instead of just picking your favorite like we do here in the US, you take all of the choices that are available to you and you rank them from your most desirable to your least desirable choice. All right, so let's take a look at an example of that and see how it works. So in this first example, we have a vacation club that is trying to decide which destination to visit this year. They've narrowed it down to three choices: Hawaii, Orlando, or Anaheim. All right, so I don't know exactly what a vacation club is. I've never been a part of one, but apparently it's a group of people that are going to go on vacation together, and they got to pick where to go. So there's 10 people in the vacation club. So we've got Bob and Ann, Marv, Alice, so forth. So all of them are listed here across the top. And what they did was they ranked the three choices, Hawaii, Orlando, or Anaheim, based on their preference. So if we look at Bob here, Bob voted to go to Anaheim first. He likes Anaheim the most, then Orlando, then Hawaii. Marv is a little bit different. He liked Orlando the most, then Hawaii, then Anaheim. All right, so this is what we call a preference schedule, right, with each individual preference ballot. Now, typically, once we have all of the votes in, what we like to do is we like to combine them and condense them into something that's a little bit more reasonable. And this is where we start getting numbers, all right? So if you look carefully through the table, you'll see that even though there were 10 people, there were only 4 different ways that people actually voted. So one of the ways that people voted was going Anaheim, Orlando, Hawaii, so AOH. And if I look up here, Bob was one of the people that voted AOH. And if I go through each individual ballot here, you'll see he was the only one. So I'm going to put a 1 up here at the top. So there was one person that voted this way. Okay. Now, another way that people voted was AHO. So you'll see here Ann voted AHO. Eve voted AHO, and Jim voted AHO. So there were 3 people that voted this way. All right, and then we've got OHA. So let me go up here. I'm going to get rid of these marks. All right, so we've got OHA, and Marv voted OHA. Omar went OHA, and Dave went OHA. And that was it. So we've got 3 people that voted this way. And then we've got HAO, so we've got Alice. Right. All right. Sorry, pen malfunction there. All right, so we've got Alice, and we've got Lupe. And let's see, so HAO, and we've got Tish, who also voted that way. So we had 3 people that voted in this order. All right, so we have 1, 3, 3, and 3. So we see our numbers going on here. Now, if we total the number of votes going across, just to make sure that I got everybody. Remember, I said there were 10 people in the club. So I have 3, 6, 9, 10. If I add those all together, I get my 10 total votes. And I always do that at the end just to make sure that I got everyone accounted for, so I don't miss any of the individual preference ballots that were submitted. Okay, so that's one of our first things that we're talking about here, is just how do we go from a simple vote to something like this where we have a preference schedule. And once we have this preference schedule, there is a number of things that we can do with it. There's all kinds of voting techniques and systems that we can apply to this thing, and that's what we're going to look at next. Okay, so we're going to talk about something called the plurality method. So now that I have all the preference ballots in, how do I decide a winner? Well, one way is using the plurality method, and this is what we do in the United States. All right, so in this method, the person who has the most first place votes is declared the winner. All right, problems with this thing, ties are possible, and so sometimes we might have to do an alternative system if there is a tie. So as we saw in our previous example, we had 3 of those preference schedules come back with 3 votes, so ties are very likely to occur when we're using that plurality method. So let's take a look. We're going to apply the plurality method to our example from that preference schedule before. All right, so for the plurality method, we only care about first choice options. All right, so if I look at Anaheim, we'll see Anaheim got 1 first place vote here, 3 first place votes here, and then that's it. Right, so Anaheim has a total of 4 first place votes. All right, then I go back to my preference schedule, and I'm going to count up how many first place votes Orlando got. All right, so none here, and then in this one it got 3 first place votes, and that's it. So Orlando got 3. All right, then we look at Hawaii, and we go over here. Hawaii's only first in this very last column, so it gets 3 first place votes, and we can see Anaheim ended up with the most first place votes, so Anaheim wins plurality with 4 votes. Okay. And notice that there is a difference there between majority and plurality. So to have a majority vote, you have to have over 50%. I kind of talk about that here. It's in the notes. A majority is over 50%. So since we had 10 people participating in this election, you would need at least 6 votes to get a majority. Now, Anaheim won the election without getting a majority. You got a plurality instead. So it had the most first place votes, but it did not have a majority of the first place votes. All right, so there is a distinction between the 2 words, majority and plurality. That's important. All right. Okay, let's take a look at our next example. Okay. So here we go. We've got 3 candidates, and they are running in an election for county executive, whatever that is. And we have our candidates Goings, which will indicate with a G, McCarthy, which will indicate with an M, and Bunny, which will indicate with a B. The voting schedule is shown below. Okay, which candidate wins under the plurality method? All right, so they were nice for us. They've already constructed our preference schedule, and notice we don't have any second or third place selections here for these 20 voters. They only gave their first preference and declined to give their second and third. Also, these 39 voters over here also decided not to give a second or third place choice. All right, but that's okay because we're doing a plurality method and we really only care about the first place votes. All right, so I'm going to go over here and I'm going to say Goings, okay, and I'm going to count up all of the G's. So we've got 44 here. So we got 44, 14 and 20, and let me do my math in my head real quick. That's 34, 74, 78 votes for Goings. Hopefully I added that up right. And then we have McCarthy. Okay, let me switch to a different color here. I'll go blue. So McCarthy has 70 first place votes here and 22 first place votes here. So if I add 70 and 22, I get 92 first place votes for McCarthy. And then I'll switch colors one more time. Let me get, let's go green. And we've got Bunny, right? And Bunny's got 80 votes here and 39 here. So that's 119 for Bunny. So Bunny is our winner. Okay, so this is, and we'll specifically call him the plurality winner. Okay, let me check my time here. All right, so let's keep going for just for another minute or two. And all right, so what is wrong with plurality? It seems like a good choice. I mean, we look at the most number of first place votes, and it seems like, well, why couldn't that be used to pick the winner? Where do we run into issues with that? And I want to show you an example actually from our travel club where they were deciding where to go. And if you remember, Anaheim was our plurality winner. Okay, so Anaheim actually had the most first place votes with, I believe it had 4 first place votes from that example. Now, let's say we take a look at what happens when I pit Anaheim versus Hawaii. Okay, so and what we're going to do here, just to show you what's going on, is we're just going to do one-on-one matchups. So we're going to take a look at what happens, like, what if Anaheim and Orlando were the only 2 choices? What would they prefer? What about Anaheim versus Hawaii? So if I just put those 2 head to head, which place would the people pick? All right. So if we look at, and I'll start with Anaheim versus Orlando, and then we'll take a look at Anaheim versus Hawaii, because this is where the problem occurs. All right. So if I look at Anaheim versus Orlando, right, Anaheim is preferred higher than Orlando here. So this person preferred Anaheim over Orlando because Anaheim is their first choice and Orlando is their second. Now here, for these 3 people, Anaheim is preferred again over Orlando, right? And these 3 had Anaheim as their first choice, Orlando as their third choice. And if I go here, Orlando is higher, but in the last column, Anaheim is choice 2, Orlando is choice 3. So again, Anaheim is preferred over Orlando by 3, 6, 7 out of our 10 voters. All right, and that's good. Anaheim was the plurality winner, and it was preferred over Orlando in a one-on-one matchup. All right, but watch what happens when we pit Anaheim versus Hawaii. All right, so if I look at Hawaii, if I go to this column with a 3 in it, look at Hawaii here. I'm sorry, not that column, but if I go to my third column here, Hawaii is preferred over Anaheim, and in the last column over here, Hawaii is preferred over Anaheim, which means 6 out of the 10 people, a majority of people, would prefer Hawaii over Anaheim, but Anaheim somehow won the plurality vote, even though the majority of people would prefer Hawaii over Anaheim. So it just doesn't seem right that if more people prefer Hawaii, that Anaheim should somehow win the election. Okay, so that leads us to what's called a fairness criterion. And let me scroll down here, and we'll talk about that real quick. So a fairness criteria are statements that seem like they should be true in a fair election, right? So like what we just saw is we saw more people preferred Hawaii over Anaheim, but somehow Anaheim won. Okay, so this first fairness criterion, there's going to be 4 of them throughout the chapter that we're going to talk about. It's called the Condorcet, and that's how this weird word right here is pronounced. It's named after the mathematician who studied it back when it was discovered. I'm not going to go too deep into that, but that's who it's named after. Famous mathematician, great guy. But it states that if there is a choice that is preferred in every one-to-one comparison, like those one-to-one comparisons that we just did, that choice should be the winner. Okay, so if I were to take every choice and just do a head-to-head matchup, and if there is one choice that beats every single other choice in a one-on-one matchup, that choice should be the winner, right? That makes sense. So we call that a Condorcet winner. But if we have a Condorcet winner and somehow somebody else wins, we violate this criterion. Okay? So I'm going to stop the lecture there for today. We'll talk more about the Condorcet winner and the Condorcet criterion in tomorrow's lecture. Make sure you try some of the practice problems right below this video. All right, guys, have a great day.